Hello students, how are you? I hope all of you are good. In this video, I am going to start the first exercise of the chapter Relations and Functions. And in this exercise, the first question has 4 sub-questions. In all that questions, we need to identify whether the given relations are reflexive, symmetric and transitive. So in this first question, this relation R defined on the set A, and A consists the elements 1, 2, 3 and so on, so 14. To write the reflexivity and symmetricity and transitivity of the given relation, here easily we may write the rooster form of the relation, because set A consists limited number of elements. So this relation he has given in set builder form. He has given in set builder form. Since set A consists limited number of elements, so we may write its rooster form, and rooster form of the relation R is equals to, see here the relation between x and y is 3x minus y, and this can also be expressed as 3x is equals to y. So therefore rooster form of the relation R is, so this relation defined on the set A, it means the values of x can be taken as 1, 2, 3 and so on, so 14. So when x is equals to 1, when x equals to 1, the value of y, 3 into 1, 3. And then next value of x is 2. So 3 into 2, y is 6. And then next value is 3. 3 into 3, 9. So value of y is 9. And then next value of x is 4. So 3 into 4, 12. And the next value of x is 5. So 5 into 3 is 15. Now observe here, this relation R defined on the set A. Set A consists only up to the 14. But this 15 is not exist in this set A. Therefore, the last pair 5, 15 is not exist in the relation R. And so on. So next because y value doesn't present in the set A. That's why the rooster form of this relation R is 1, 3, 2, 6, 3, 9 and 4, 12. Now observe here. So I already discussed in my introduction part of the exercise first. So reflexive relation means how many number of elements are exist in the set A or defined set. All elements must be related to itself. So by observing this rooster form of the relation, we conclude that 1, 1, because A set consisting 1, 2, 3 and so on, so 14. So observe here, since 1, 1, 2, 2 and so on, so 14, 14 are not exist in this relation R, which implies R is not a reflexive relation. R is not reflexive relation. I hope all of you understood. Now for the second symmetric relation, we know that if the pair AB exists in the relation R, it means there must exist the pair BA. If both of these two pairs are in relation R, then we call it as it is a symmetric relation. Now observe here. So here you may write one more thing here. Since 1, 2, 3 and so on, so 14 belongs to set A. Since their doublets are not exist in the relation R, that's why it is not a reflexive relation. Now for the symmetric relation, so see here, for all, observe this first pair 1 and 3 belongs to the set A. Since the pair 1, 3 belongs to R, but its opposite order 3, 1 does not in the relation R, does not exist in the relation R, which implies R is not symmetric relation. R is not symmetric relation. I hope all of you understanding. So you may consider any example. So 2, 6 ada, 6, 2 illa, 3, 9 ada, 9, 3 illa. So you may give any one example. So I give it here 1, 3 and 3, 1. Since 1, 3 exist in the relation R, but 3, 1 is not exist in the relation R, that's why it is not a symmetric relation. Now for the transitive relation, we know that the definition of transitive relation is if the pairs AB and BC in the relation R, if there exists the relation AC, then we call it, then there exists the pair AC in the relation R, then we call it as a transitive relation. Now observe here, 1, 3 is in R and 3, 9 also in R, but 1, 9 is not in the relation R. So it means it is not a transitive relation. See here, for all 1, 3 and 9 belongs to the set A, since the pair 1 3 belongs to R and the pair 3 9 belongs to the R, but the pair 1 9 does not belongs to relation R. So which implies this relation R is not transitive relation. It means this relation R is not transitive relation. Transitive relation. I hope all of you understood this question. So this question is important question asked in your annual examination for the 3 mark. I hope all of you understood. Now let's start the next question. And the second question is relation R defined on the set N of natural numbers, and the relation between x and y is equals to x plus 5, and he also given that where x is less than 4. So here this relation R is defined on the set of natural numbers, and we need to identify whether this relation R is reflexive, symmetric or transitive. Since the values of x is limited here, so set may consist infinite number of elements. So the natural numbers are in infinite numbers, but the value of x is limited here. So we should take the value of x should be less than 4 and it should be one of the natural number. Therefore, the values of x possible here are x equals to 1, 2 and 3. So except these three we cannot take any value of x, because he has given that x should be one of the natural number and x should be less than 4. Now therefore the rooster form of this relation R is, observe here the relation between x and y is equals to x plus 5. So when x is equals to 1, the value of y is 1 plus 5, 6. And then when x equals to 2, 2 plus 5, 7. And then when x equals to 3, 3 plus 5 is 8. So these are the only three pairs exist in this relation R. Now observe here, since in this relation R, so the elements 1, 2, 3 and so on so exist in the set natural numbers. So therefore the pair 1, 1, 2, 2 and so on so does not exist in this relation R. So which implies R is not a reflexive relation. R is not a reflexive relation. And for the symmetric relation, observe here the pair 1, 6 in relation R, since for all the numbers 1 and 6 in set of natural numbers, and the pair 1 6 in relation R, but the pair 6 1 is not in the relation R, which implies this relation R is not a symmetric relation. And one more thing, we need to observe the transitivity of this relation. See here, just observe this relation R. Here the pair 1 6 is exist, but 6 is not belongs to, or 6 is not related to any other. And 2 7 is in R, but 7 is not related to anyone. And 3 8 is in R, but 8 is not related to anyone. So we know that if the pairs AB and BC in R, then there must exist a pair AC in R. And also, or you may define the transitive relation in other words, that is what, if the pair AB belongs to R, but there does not exist the pair BC in R, then we no need to check the pair AC idru onde irlilla andru onde irok chance illa. If the pair AB in R but BC is not in R, so then definitely AC not belongs to R. If the pair AB in R but B is not related to any other, then also we call it as a transitive relation. Since in this relation R, only the pair AB is exist, but B is not related to any other, or BC is not exist. So that's why we say that this relation R is one of the transitive relation. So ಬರೆಯೋದು ನೋಡ್ರಿ ಹೆಂಗ್ ಬರೀತೀರಿ, it can be observed that there does not exist there does not exist the pairs AB in R and BC in R, which implies R is a transitive relation, I hope all of you understood. Nodri ನಾನು ಏನು ಬರ್ದೇನೆ ಇಲ್ಲಿ, there does not exist the pairs AB and BC in R, that's why it is a transitive relation. I hope all of you understood this question. Now let's start the next question. And the next question is third question of the first one. So here in this question also he has given that one of the relation R on the set A consists the elements 1, 2, 3, 4, 5, 6. And the relation is the second element Y is divisible by the X. So first element divides the second element. This is what relation between first and second element. So here also we may write the Brewster form of this relation. So therefore R can be written as, see here we know that every element divisible by itself. So it means the pairs 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6 are in the relation R. Why? Because every number is divisible by itself. And then 1 divides every element. It means 1, 2 present, 1, 3 exist, 1, 4 exist, and then 1, 5 exist, 1, 6 exist. And then 2 divides 2 bardiri, 2 divides 4 and then 2 divides 6, then 3 divides 3 and 3 divides 6 and then 4 divides 4 bardiri. So these are the only elements. Just only 2, 4, 6, 8, 10, 12, 14. So these are the only 14 pairs are exist in this relation R, and we need to check whether this relation R is reflexive or not. See here. So first observe here, every element 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. It means every element related to itself. It means this is a reflexive relation. So ಬರೆಯೋದು ನೋಡ್ರಿ, reflexive ಇಲ್ಲ ಅಂದ್ರೆ you may give the examples. If it is reflexive, then we need to write it by using the definition. So ಯಾವ ರೀತಿ ಬರೀತೀರಿ ನೋಡ್ರಿ, for all elements exist in the defined set A, there exist the pairs, since the pairs AA in the relation R, which implies R is a reflexive relation. I hope all of you understand it. Now for the symmetric relation, observe here, the pair 1, 2 is in R, but 2, 1 is not in R. 1 divides 2, but 2 not divides 1. So that's why 1, 2 is in R, but 2, 1 is not in R. So since the elements 1, 2 belongs to the defined set, since the pair 1, 2 belongs to R, but the pair 2, 1 does not belongs to R. So which implies R is not a symmetric relation. R is not a symmetric relation. I hope all of you understood. If at least one pair is not in the form of AB and BA in the relation R, then it is not a symmetric relation. So now we need to check whether this relation is a transitive or not. So see here, this relation has 14 number of elements, so it is hard to check whether it is transitive or not. But we have a logic. See here, if A divides B and B divides C, then definitely A divides C. So for example, we know that 2 divides 4 and 4 divides 8. It means 2 definitely divides 8. And as well as 5 divides 10, 10 divides 20, 5 divides 20. Or 10 divides 30, 30 divides 60, and also 10 divides 60. AB, BC and AC. AB, BC and AC. AB, BC and AC. So it means it is a transitive relation. See here, if it is a transitive relation, we need to write by using the definition of transitive relation, not by considering the examples. Since it is a transitive relation, you may check anywhere. 1, 2 is present, and then 2, 6 is exist. 1, 2, 2, 6. It means 1, 6 irbeku other. As well as now observe 1, 3 is present. 1, 6, 3, 6 is present. Then definitely 1, 6 also exists in this relation. So therefore this is a transitive relation. So for that, let us consider for all A, B and C belongs to the defined set A, there exist a pairs AB belongs to R and BC belongs to R. There exists the pair AC in the relation R. So you may give the example. For example, 1, 2, 6 belongs to the set A. Since the pair 1, 2 in R and 2, 6 in R and 2, 6 in R, there exists the pair 1, 6 also in R, 1, 6 also in R. So which implies R is a transitive relation, which implies R is a transitive relation. I hope all of you understood this question. Now let's start the next question. And the fourth question in first one, that is what? This is also one of the relation defined on set of integers, set of all integers. And the relation between x and y is x minus y is an integer. X minus y is an integer. See here, this set Z consists infinite number of elements and there is no condition on x and y. It means this relation R consists infinite pairs, infinite pairs. So here not possible to write all the elements of the relation R. So we cannot write it in a rooster form. So but we know that if you consider any two integers, you may consider any two integers, then that difference between them 2 minus 4 definitely one of the integer, definitely one of the integer, or you may consider 5 and 10. So it is also one of the integer. Either reverse to 4 minus 2, this is also equals to 2, 2 is one of the integer. Either reverse to 10 minus 5, which is equals to 5, 5 is also one of the integer. Or 2, 3 and 5 consider my order. 2 minus 3 is minus 1, 3 minus 5 is minus 2, then 2 minus 5 is minus 3. So 2, 3 belongs to R, 3, 5 belongs to R as well as 2, 5 belongs to R. You may consider 1, 6, 7. 1 minus 6 minus 5 is one of the integer. 6 minus 7 minus 1 is also one of the integer. And 1 minus 6 is minus 6, it is also one of the integer. So, and you may consider 1 and 1. So 1 minus 1, 0, 0 is an integer. 2 minus 2 is 0, 0 is an integer. So it means this relation is reflexive, symmetric as well as transitive. This relation R is reflexive, symmetric and transitive. So therefore we may write for all elements belongs to the defined set of integers, since a minus a is equals to 0, 0 is one of the integer, which implies every element in the set related to itself, it means R is one of the reflexive relation. R is one of the reflexive relation. I hope all of you understood. Now for the symmetricity, for all A and B belongs to the defined set Z. Let us consider the pair. One pair ನಾನು consider ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಯಾವುದು? AB. AB belongs to relation R. Why? Because A minus B is one of the integer. A minus B is an integer. See here, if 2 minus 4 integer, then definitely 4 minus 2 is also integer. So it, which implies B minus A is also an integer, is also an integer. So which implies the pair BA exists in the relation R. So it means R is one of the symmetric relation. So which implies R is a symmetric relation. R is a symmetric relation. I hope all of you understood. Now for the transitive relation, consider three elements A, B, C belongs to defined set of integer. Consider two pairs. Let the pair A, B belongs to relation R and BC belongs to relation R. So as I discussed, if 2 minus 4 integer and 4 minus 8 integer, then definitely 2 minus 8 is also integer. I hope all of you understood. Since pairs AB and BC in R, which implies definitely A minus B is an integer, is an integer. and also b minus c is also one of the integer, is also an integer. Now see here, if 2 minus 4 integer and 4 minus 8 integer, then definitely 2 minus 8 is also integer. First pair, second pair and third pair, which implies definitely a minus c is also an integer, is also an integer. Since a minus c is an integer, which implies the pair AC is also in the relation R. Since the pair we consider here AB in R and BC in R, and we proved the pair AC is also in R, which implies the relation R is also a transitive relation, is also one of the transitive relation. I hope all of you understood. This question is important, asked in your annual examination for 3 marks. And one more thing you need to observe here, since this relation R is reflexive and symmetric and transitive relation, then definitely this R is one of the equivalence relation. equivalence relation equivalence relation. So ಇದನ್ನ ಎಕ್ಸಾಮ್ ನ ಯಾವ ರೀತಿ ಕೇಳಿದ್ನಪ್ಪ ಅಂದ್ರ, prove that this relation is an equivalence relation ಅಂತ ಕೇಳಿದ್ರು. And now the fifth question, and the fifth question also has the sub questions. This is main question is first question idradu, but first question alli fifth question has the sub questions. And this fifth question is, here he has given that some of the relations depend on the set A. A is set of human beings. What is set A here? Set A consists some of the human beings. A is set of human beings, and on this set he has to define one of the relation, and the relation between x and y is x and y work at the same place. The relation between x and y is what they are working at the same place. So this is one of the easiest question. Now mind ಒಳಗೆ solve ಮಾಡಬಹುದು ಇದನ್ನ. See here, one of the person x and another person is y. If x and y work at the same place, andru ಒಂದೇ statement y and x also work at the same place. And if suppose x and y work at the same place and y and z work at the same place, then definitely x and z also work at the same place. I hope all of you understanding. ಈಗ 1 ಅನ್ನೋ ಒಬ್ಬ ಪರ್ಸನ್ ಅದನ್ನ, 2 ಅನ್ನೋ ಒಬ್ಬ ಪರ್ಸನ್ ಅದನ್ನ, 3 ಅನ್ನೋ ಒಬ್ಬ ಪರ್ಸನ್ ಅದನ್ನ. 1 and 2 ಒಂದೇ ಪ್ಲೇಸ್ ನೇ ವರ್ಕ್ ಮಾಡ್ತಾ ಇದಾರೆ, 2 and 3 ಒಂದೇ ಪ್ಲೇಸ್ ನೇ ವರ್ಕ್ ಮಾಡ್ತಿರ್ತಾರೆ, then definitely 1 and 3 also work at the same place. And for the reflexivity ನೋಡ್ರಿ ಏನಂತ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾರೆ ಇದನ್ನ. Reflexive means every element of the set A related to itself. For example, x na compare ಮಾಡಿದ್ನಪ್ಪ ಅಂದ್ರೆ, x is one of the person, definitely x and himself work at the same place. For example, me and myself work at the same place. And Bhumi ಅಂತಿದ್ದಾರೆ, Bhumi and herself work at the same place. I hope all of you understood the definition of this reflexivity. ಏನು ಹೇಳ್ತ ನೋಡ್ರಿ, for all members in the set A and himself or herself work at same place. So which implies the pair AA is in the relation R. So which implies what? R is a reflexive relation. I hope all of you understanding. Now for the symmetricity, see here. For all two members, let us consider two members here. A and B are any two members exist in the set A, and let the pair AB in R. ನಾನು ಕನ್ಸಿಡರ್ ಮಾಡಿರೋ pair. ಯಾಕೆ ಕನ್ಸಿಡರ್ ಮಾಡೀನಿ? These two members A and B work at same place. If A and B work at the same place, it's reverse. B and A also work at the same place. It means the pair BA is also exist in the relation R. It means what? R is a symmetric relation, which implies R is a symmetric relation. It means R is a symmetric relation. I hope all of you understanding. Now for the transitivity relation. Now for the transitivity relation, consider any three elements for all. For all A, B, and C belongs to the defined set A. And let us consider two pairs A, B, and B, C. Let us consider the pairs. Let the pairs A, B belongs to R and the pairs BC belongs to R. Now check whether A and C also belongs to R. So see here I considered the pair AB in R, which implies A and B work at same place, work at same place, work at same place. And BC belongs to R in the sense B and C also work at same place, work at same place. Now see here which implies the pairs A and C. It implies if A and B work at the same place and B and C work at the same place, then definitely A and C also work at the same place. A and C also work at work at same place, which implies the pair AC belongs to R. I hope all of you understood. Since AB belongs to R and BC belongs to R, as well as the pair AC belongs to R, which implies R is a transitive relation. R is a transitive relation. I hope all of you understood. Now, here since this relation R is a reflexive relation and symmetric relation as well as a transitive relation, it means this relation R is a equivalence relation. Equivalence relation. I hope all of you understood this. Now let's consider the next question. And the next question is, so here also one of the relation on the set of human beings, and the relation is nothing but X and Y live in the same locality. They are living in the same place only. Agala ಏನਿತ್ತು work at the same place ಇತ್ತು, but now the relation between this X and Y is they are live in the same locality. ಒಂದೇ place ನೊಳಗೆ ಜೀವಿಸ್ತಾ ಇದ್ದಾರೆ. So same thing, A and itself or himself or herself live at the same place. If AB live at the same place, then BA also live at the same place. If AB live at the same place, B and C live at the same place, then definitely A and C is also live at the same place. ಇವೆಲ್ಲ ಮೈಂಡ್ ಅಲ್ಲೇ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಬರಿ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಅನ್ನೋದಕ್ಕಿಂತ ಮೊದಲು ಮೈಂಡ್ ಅಲ್ಲೇ ವಿಚಾರ ಮಾಡ್ಬೇಕು ವೆದರ್ ದಿಸ್ ರಿಲೇಷನ್ ರಿಫ್ಲೆಕ್ಟಿವ್ ಆಗುತ್ತಾ ಇಲ್ಲೋ, ಸಿಮೆಟ್ರಿಕ್ ಆಗುತ್ತಾ ಇಲ್ಲೋ, ಟ್ರಾನ್ಸಿಟಿವ್ ಆಗುತ್ತಾ ಇಲ್ಲೋ. So it is easy to write. Now what we need to write, expressing the answer is very important here. Writing the answer is very important here. ರಿಲೇಷನ್ ಅಲ್ಲಿ ಏನು ಇಂಪಾರ್ಟೆಂಟ್ ಇರುತ್ತಾ, ನೀವು ಯಾವ ರೀತಿ ಬರೀತೀರಿ ಅನ್ನೋದ್ರ ಮೇಲೆ ಇಂಪಾರ್ಟೆಂಟ್ ಇರುತ್ತೆ. Same thing for all. Consider any one person A belongs to the defined set A. We know that A and himself, A and himself, or you may call it as herself. Herself live live in the same place. Live in the same place. I hope all of you understanding, which implies the pair AA belongs to relation R. Similarly, let us consider the pairs or a members A and B belongs to the set A. Let us consider one pair AB belongs to relation R. If this pair AB in R, definitely A and B live in the same locality. Live in the same locality. In the same locality. Andru ಒಂದೇ B and A also live in the same locality. Live in the same locality. So which implies the pair BA belongs to R. Since the pair AB in R and BA in R, which implies R is a symmetric relation. R is a symmetric relation. I hope all of you understanding. Now for the transitivity relation, let us consider three members in the set A. For all A, B and C belongs to the defined set A. So let us consider the pairs AB in R and the pair BC in R. So if AB in R, which implies A and B live in same locality and B and C live in same locality, which implies definitely A and C live in same locality. Same locality. So which implies R is a, which implies, first thing you need to write the pair, which implies the pair AC belongs to relation R. Since AB belongs to R and BC belongs to R, as well as the pair AC in R, which implies R is a transitive relation. R is a transitive relation. Now observe here, since this relation R is a reflexive relation, since this R is a reflexive relation and symmetric relation and transitive relation, hence this R is what? One of the equivalence relation. One of the equivalence relation. I hope all of you understood this question.